The question, did Pythagoras use the diddley bow to discover music theory? So I asked ChatGPT what the connection was between Pythagoras, music theory, the monochord, the diddley bow, and harmonics. This is what she said, with just a couple corrections.
All right, you've just summoned a fun intersection of math, music, and history. Let's unpack it step by step so the pieces fit together. 1. Pythagoras and music theory. Pythagoras, c. 570–495 BCE, isn't just the triangle guy. He's also credited with discovering the mathematical ratios that define musical harmony. According to tradition, Pythagoras noticed that plucking strings of different lengths produce different pitches. He found that simple ratios of string lengths produce consonant intervals. 2:1 in octave, 3:2 equals perfect fifth, 4:3 equals perfect fourth. These discoveries laid the groundwork for Western tuning systems and the idea that music could be explained mathematically. 2. The monochord. A monochord is essentially a single string stretched over a resonating box with a movable bridge. By sliding the bridge and measuring string lengths, you can demonstrate Pythagoras' ratios in a clear physical way. Ancient philosophers and medieval scholars used the monochord for teaching tuning, intervals, and even planetary harmony, music of the spheres. It's basically a laboratory for exploring pitch. 3. The diddley bow. The diddley bow is a one-string instrument from African American folk tradition, especially in the rural South of the United States. It often consists of a wire nailed between 2 points on a wooden plank, played with a slide, like a glass bottle. It's considered a cousin of the monochord. Both are single-string instruments, but the diddley bow is more about blues and groove than laboratory precision. Many blues guitarists learned on one before moving to a full guitar, for example, Bo Diddley, from which he gets his name. 4. Harmonics. Harmonics are overtones produced when you lightly touch a string at specific points instead of pressing it down fully. These points divide the string into equal segments, naturally producing the same ratios Pythagoras identified. Example: touch at 1/2 the string length in octave, 2:1 ratio. Touch at 1/3 the string length, perfect fifth above the octave, 3:1 ratio overall. Touch at 1/4 the string length, 2 octaves, 4:1 ratio. On both monochords and diddley bow, harmonics are a direct physical demonstration of the mathematical structure of sound. In short, Pythagoras gave us the math. Monochord lets scholars measure it. Diddley bow put it in the hands of blues musicians. Harmonics show that nature itself plays by the same rules.